Welcome back everybody to a brand new Unity tutorial where today we're going to have some fun building this quick and simple maze tilting game. Best of all, you can download this project from the link in the description and follow along at home. So, when you're ready, grab your puzzle books, let's crack on. Upon opening the project, you will see we have a partly constructed maze. How this maze has been constructed is as follows. We have the parent maze game object here at its default transform. I've added an icon so that we can see the point in which we will pivot the rotation of the maze, that is at the center of the base of the parent game object. Inside this maze object, we have the maze floor and another parent object inside containing various maze cell prefabs. Each of these cells is one unit within our maze, and our maze is 7 by 7. Let's go ahead and have a closer look at the maze cell prefab. And here, inside the maze cell, are 4 walls which are named top, bottom, left, and right. What we will do is simply deactivate the walls we don't want when we place them in our scene. If you go ahead and deselect the top wall, you'll see that they disappear in the game view as well. So, let's go ahead and use these maze cells to finish our maze. Simply drag and drop the prefab into the maze cell parent. Holding Control, click and drag it into place like so. Then let's just set inactive the walls we don't want. I'm going to set inactive the top wall, and we already have a wall at the bottom there, so I'll deactivate the bottom as well. So, let's repeat that process to fill in the last cell of the maze by holding Ctrl and D to duplicate. And let's drag this one up just like so. And I'm going to keep the right wall and set inactive the left wall. And there we go. Our maze is now complete. Let's get this maze moving by creating in the scripts folder a board controller script and add it to the maze parent object and go ahead and open it up. Okay, so for the variables, we have a public float rotation speed and a public float for clamp angle. In order to avoid rotating the maze too far and the ball rolling out, we're going to clamp the angle on both axes to this value. That way we have much better control. Then below we have 2 private floats, one for the current rotation on X and the current rotation on Z, and their default is set to 0F. Alright, so after that, let's skip start, go straight to update, and let's write our inputs first. We want to rotate on the X axis whenever we press up or down, and we want to rotate on the Z axis when we press left or right. Now you might be thinking, well, normally vertical is up and down, right? Up and down inputs. Well, how this project is set up, with the camera's position, the Z-axis will be forward and backwards, and the X-axis will be to the side, and it will make sense in a moment. So for now, we'll create a float till X equals input.getAxis horizontal, and likewise float Z input.getAxis vertical. Then we want to calculate the rotation amount for both those axes, and we'll do that using the current rotation float in our variables. So the current rotation X will plus equal the value of the input till X multiplied by the rotation speed multiplied by time.delta time. And likewise, we'll just do the same thing for the current rotation Z plus equal the input tilt Z by rotation speed by time.delta time. Then we want to use that clamp angle to clamp those axes to prevent excessive tilt. And again, we'll use the current rotation X equals mathf.clamp, then the values we wish to clamp it on and the axis. So we want to clamp the current rotation on X minus our clamp angle and our clamp angle. That way, we don't need to input 2 values. If it's 25, it'll be positive and negative 25. And for the Z, same again, current rotation Z equals mathf.clamp on the Z axis, and again, via that same minus clamp angle. And of course, we don't want the y-axis to move at all. Sometimes the rotation can affect the other axis. We only want to focus on x and z. So we'll put here transform.rotation equals quaternion dot Euler, and then inside we'll have the current rotation of x, 0 for the y, and the current rotation of z. That way it will not move on the y-axis and it will always be 0. We're only going to manipulate the x and the z. With that done, hit save and let's head back into Unity. All right, once it's all compiled, let's go to the board controller script in the inspector and punch in our rotation speed. I think a value of 50 is fine. And for the clamp angle, let's go with something quite short. Let's go with 25 degrees. Then hit play, and you should now be able to move the maze in all directions. So if we're using left and right, you can see how it makes sense now, the inputs in relation to the camera. And let's do up and down, tilting further away or closer. And you can see we've clamped it, so no matter how far you move in any one direction, it will not go beyond that clamped value. Right, now we have this maze moving, let's create a ball to put inside and start rolling around. To create the ball, we're not going to do anything fancy. We're just going to right click 3D object sphere. Let's name it ball. And let's reset its position in the inspector and raise the ball a little higher so we can see it. We also want to scale the ball down so it fits nicely within the paths of the maze. I think a value of 0.75 on each of the axes works quite well. There we are. And we want to use physics to get this ball rolling as we tilt the maze. So let's add a rigid body component. Let's change the angular drag to 0. We want nice smooth movement. Gravity checked. And the collision detection set to continuous. There we go. Let's also give this ball some color. If you go into the materials folder, I have 3 colors prepared. If you'd like to create your own, you can right click, create material, and you will get something that looks like this. A standard shader, and you can select your color in this box here, and there is your color palette. I quite like this shade of red, corn red, so I'm going to apply that to my ball by dragging the material in the inspector just like so. There we are. Let's position the ball in the top corner of the maze over there by holding down Control and dragging it along the grid just like so. There we are, get it at the top corner there. When we take a look at it from the side, we want to lower the ball and put it in a position where it is just above the surface of the floor, just like so. There we are, let's get a good view of that. That looks pretty good. Then I'd like you to go ahead and hit play. And you'll see that the ball initially does not make contact with the maze and just falls right through, just like it is there. That's because the maze itself, we're moving it via control, and it just has standard collision, whereas the ball has a rigid body component and is therefore making physics collisions. In order to fix this problem, all we have to do is select the maze parent object, add component, a rigid body. And we don't want any angular drag. We certainly don't want gravity, as we're controlling this via input. We'll set is kinematic true, and we'll leave collision detection as discrete. Now when you go ahead and hit play, the ball now makes clean collisions with the floor and the walls of the maze. And there we go. We have created a simple maze that we can rotate via directional inputs in order to roll a ball to navigate from one corner to the next. Feel free to experiment with this. Create as large a maze as you like, or a smaller maze. You can even create multiple mazes to mix and match or connect them all together. The choice is yours. In the next video, we're going to look at creating a little goal section to put into the maze, as well as a countdown timer and general game manager functions, such as a win condition. Thank you all very much for watching, guys. I very much do appreciate it, and I'll see you all in the next part. Take care.